Okay, so the z-score, how do we find the z-score?
Minus the x.
X minus the mean. We always start with your value.
Oh.
Always start with your value. So z-score is equal to your x value minus the mean over the standard deviation. So you're going to find a z-score. Since these are my two x's, I have two x's, I need to find the z-score for each of them. I need to find the z-score for 560, and I need to find the z-score for 780. And again, normal CDF, you have to do second bars, again, to get to that. It'll be your lower z-score, comma, your upper z-score. Leave your mean at 0, standard deviation at 1. Okay, let's take a look at the z-scores. So the first z-score is going to be 560 minus the mean divided by the standard deviation, 0.96, and y'all got negative
1.335.
1.335 or
35.
3.5. Okay. And then the second z-score was for 780. So 780 minus the mean over the standard deviation. And for that one, you folks got
0.94.
94. Great. And then we did our normal CDF. So normal CDF of the lower z-score, comma, the upper z-score. And I'm going to draw a little picture so we get a better sense of what's going on here. So here's my middle. I have z-score of negative 1.35 over here. I have a z-score of positive 1.94 over there, and I'm finding the area between them. So the shaded area between them. So I'm going to do normal CDF of negative 1.35, comma, 0.94, and you got help me out, I have no idea. 737?
Yeah.
Okay, good. As a refresher, how do you find that? Go to your calculator. We're going to do second bars down to normal CDF. Put in the lower z-score. Remember, for negatives, you cannot use the subtraction sign. I'll give you an error. You have to use the negative sign next to the enter key. Negative 1.35, comma, 0.94. And if you have the fancy calculator, leave your mean at 0 and standard deviation at 1, or it'll mess you up. 738.738. Good. So the last question is, what does that mean, 0.738? What does that mean in the context of entrees? What does that mean in terms of entrees? Anyone? Talk to your neighbors for a second. Find your neighbors, chat for 30 seconds. Okay, so remember, this area under the curve, that's my 0.738. That's where 0.738 lies. It's inside of here. Right, this is 0.738. It represents the area under the curve, which is the same thing as probability, and the same thing as percent of population. Those three things, that means all three things. All three of those things. So someone give me one possible interpretation. There's really two main ones. Jason, what was yours?
I put the probability that the entrees are between 560 to 780
Is
73% or 74%.
Yeah, 74%. The probability an entree costs between 560 to 780 is 74%. Good. About 74%, roughly when you round. Great. Rafa, you had something slightly different, but it was still accurate.
So it was the percent of population for the entrees are between 560.
So 74% of all entrees?
Yes.
Yep.
Well, entrees lie between
Cost between?
cost between in this case
Mm-hmm.
$5.60 to $7.80.
Mm-hmm. 560 and 780. So either one of those is a perfectly fine interpretation. They're essentially the same. Percentage population between those two values is the same as the probability of picking one and having it be between those two values.
Right now.
Right. Like if 30% of people watch the Super Bowl, then what's the probability I pick someone that watched the Super Bowl? 30%. Right? Okay, pretty good. So that is the normal distribution. Now, what about this problem? So, like the rats have a mean of 115, standard deviation of 16. So first, let's do the bottom problem first. So I want to do the bottom problem first. What kind of problem is it?
Normal distribution.
What was that? Normal distribution? Yep, it's a normal distribution problem. And what am I trying to find?
Probability.
Probability. So it's probability for a normal distribution. So it's really almost the exact same problem you just did in many ways. So I want to work on the bottom problem. Okay, so first you found the z-score, I believe, yes? That's normal distribution. You got to find the z-score, draw a picture. So z-score for this guy is going to be his value, 112, minus the mean, 115 divided by the standard deviation, 16, and you got a z-score of negative. Anyone? 0.1875. Great. So I'm going to draw a little picture, so I have a picture of this. So my z-score is on the negative side, negative 0.1875, and I want above this or below this?
Below.
Below, less than. Less than is below. So I'm going to do that, which means my other z-score is going to be what?
Negative.
Negative what?
Infinity.
Infinity, exactly. Negative infinity. We're doing some of these as review. So then I'm going to do normal CDF of what and what?
Negative 23, and then the upper is a negative.
Yeah, some huge negative number, like negative 2023, comma, the other one, negative 0.1875. Let's go ahead and do that. Second bars, normal CDF. Yeah, just get practice doing that normal CDF. It's been a long time, right? Negative, I'm just going to 222 because it's just easy, it's large. Negative 0.1875. And we get 0.4256. 4256. That is the value inside the shaded area. And that's a probability, that's the percent of population between, that's less than, has a z-score less than negative 0.1875 or has a weight less than 112. So now, are we feeling okay with this one? Okay, we'll do another one. Do you see that similar to the last problem?
Yeah.
Okay. So we can take a look at this. So again, anytime you have this normal distribution, I think it's helpful to draw a picture. But your first thing when you're looking at normal distributions is find the z-scores. So find the z-scores, draw your picture, shade the direction you want, and that kind of tells you what to put in for the normal CDF. Since it's less than that amount, and they only gave me one number, so it means I need to either use negative infinity if it's less than, or positive infinity if it's greater than. So I'm going to use negative infinity. You can use any large negative number for negative infinity, like the year, any large negative number you want. Okay. So now, the question I'm asking you next is, what is the difference between the top question and the bottom question? They are different. How are they different?
there's more than one rat.
Yeah, and the first one is more than one rat. It's a sample of 36 rats, and they're average. This one here is just one rat. So that's like the Steph Curry games. Steph Curry, can he have a 50-point game?
Yes.
Yeah, he had one just a few weeks ago. If I take an average of 36 of his games, is that average of 36 games, randomly selected games, is that ever going to be 50 points?
Mm-hmm.
No, because the outliers are going to balance each other out, right? The FAR scores. So when you're talking about an average of a bunch of them, your standard deviation is going to be a lot smaller. It's not going to vary this much. It's going to vary like this much. So your standard deviation, instead of using sigma for your standard deviation, you need to use sigma x bar. Right, this is central limit theorem. Whoops.
Oh, yeah,
Central limit theorem. Which means that instead of using x bar, you're going to, sorry, instead of using sigma, you're going to use sigma x bar. My bad. I don't know what I was saying. Which is sigma over square root of n. So, is this sounding familiar to folks? So, instead of using 16 as my standard deviation, I'm going to use 16 over square root of what?
36.
What do folks think?
36, yeah.
Yes? No?
36.
36.
36.
Yep. So 16 over 6, which is 2.67. Okay, so when I do my, z-score, 112 minus 115, instead of doing 16 here, I'm going to put in 2.67. Sigma x bar. That's going to give me a much different standard deviation. So everybody find that one. Find the probability. Okay, let's see where we're at with this. Okay, so what did folks get for this z-score?
Negative 1.12.
Negative 1.12.
Yeah.
Okay.
Yeah.
All right. So again, I'm going to do my little picture here. That's a little bit further away, right? Negative 1.12. So it's a much smaller area. So when I do normal CDF,
Negative 2023.
again, negative 2023. But now my other end at negative 1.12. What do we get?
0.1313.
130 or 1313?
1313.
Oh, because you did 1, 2 instead of 1, 2, 5. Yep.
Yeah.
Okay, that works. Yeah, 130 or 131, either one's okay. So that's much different. That's a much smaller area. Right? A lot fewer people are below that than are below, for one rat. Okay, great. So now we're going to jump back a little bit to problem number 5. We need to do this one. So find a weighted mean of the following. So this is similar to scores in a class, right? You have scores. Each score has a weight. So you have to multiply across, add them up, and then divide by the sum of the weights. I'll give you folks a couple minutes for this one. Take a look. So again, I'm going to multiply every score by its weight. So I'll get 16. I'll get 11.1. I'll get, anybody in this one?
36.45.
36.45.
Mm-hmm.
And
13.4.
32.4.
13.
13.4. Okay.
13.
And when you add them all up, you get 9, 5, 6, 7, 76.1. And then, again, you're going to divide by the sum of the weights. So those add to 1, so I'm going to divide by 1, and I will get 76.9. That is my final answer. Good. Very often you're gonna get, one for the sum of the weights often with these, we're in terms of talk about grades. We're gonna talk about grades like that. All right, now I'm gonna jump up to 13, or 11, sorry. I'm gonna jump up to 11. I'm gonna stop the video here though.